Guys, welcome to the Raptors, a digital platform of the RAPT Excellent Tutorials. Today we are going to discuss physics question paper the exam was yesterday. The exam was held yesterday, and the question paper unexpectedly was easy to moderate, and I hope all of you must have had very good day with the paper. Before you guys get into the chemistry preparation, it will be useful if we discuss a question paper, and then you can match your marks. How much you score, you are scoring, and how much you need to put effort for the upcoming exams. So stay tuned, guys. So the first question, it is very interesting question. You see, a 500 nanometer photon is incident normally on a perfectly elastic reflecting surface and is reflected, the value of momentum transferred to the surface. So there is a metal surface on which a photon with momentum p falls on it, and it gets perfectly reflected. Let the final momentum is p, then initial momentum is just in the opposite direction, let it be minus p. So what is change in momentum? Delta p is equal to final momentum minus initial momentum. So final momentum is p, initial momentum is minus p, so it is 2p change in momentum. This change in momentum is transferred to the metal surface. So this is metal surface. Now, what is momentum? Now we use de Broglie's equation. Lambda is equal to h by p, so p will be h by lambda. So put the value, 6 months. Lambda is 500 to 10 power minus 9 meter. So if you solve it, 10 power minus 11, so 5 1 is 5, and 1 5 3 is 15, 5 2 is 10, 1 5 3 is 15 into 10 to the power 11. Subtract 11 from 34, so it becomes 23 minus 23. So it is kg meter per second. Sorry. So this won't be minus 11, this would be minus 7. So minus 27. So we find out the momentum. Momentum is using de Broglie equation, lambda equal to h by p. If we solve, we get 1.323 10 power minus 30 27. Therefore, momentum transferred equal to delta p, which is 2 of magnitude of p, which is 2 into so it comes out to be 6 4 6 2 to 10 power minus 27 kg meter per second. So the correct answer is C. So C is your answer for 1. It was very interesting. Move to question number 2. It says a good diode, that is ideal diode, when checked by a multimeter should indicate. So, ideal diode, you see, if you draw IV characteristics, it has got forward bias current in milliamperes and reverse bias current in microampere. So, in microampere, it relatively remains in switched off position, but you see in forward bias, even on application of 1 volt, the current picks up. So in forward bias there is very low resistance, and in reverse bias ideally it should have infinite resistance. So the correct answer comes out to be A. So answer will be A. So a diode, an ideal diode, should have a very low resistance in forward bias and infinite resistance in reverse bias. In this question, there is a square loop of side 0.5 meter, and it is placed in a magnetic field of 0.4 Tesla, such that the magnetic field is perpendicular to the plane of the loop. That means, you know, for any loop, the the area vector makes 90 degrees with the with the with the with the plane of the area. So this is area vector, and magnetic field is also making, it is also perpendicular, so magnetic field is also making an angle of like 0 degree with the area. So initial flux. Now the question says the loop is rotated through an angle 60 degree in 0.2 seconds. The value of EMF induced in the circuit. So we use Faraday's law of electromagnetic induction, where it says the induced EMF in the loop is rate of change of magnetic flux. So EMF will be minus d phi by dt. If there are n turns, so it will be minus n d phi by dt. We are concerned about the magnitude of the EMF induced, so we will take magnitude. Now, number of turns is equal to 1 here. There is single loop, and then side of the square is 0.5 meter, 0.5 meter. Area of the loop becomes 0.5 into 0.5, so it is 25 into 10 power minus 2 meter square. Now, the loop is rotated by 60 degree. So now the area vector makes an angle 60 degrees with the magnetic field. So EMF induced will be flux final minus flux initial divided by time taking. So flux final will be B dot A cos 60 degrees minus B dot A cos 0 degrees divided by time taken is 2 seconds, 0.2 seconds. So this is 0.2 seconds. So it becomes, if you take BA common, B is 0.4 Tesla, area becomes 225 into 10 power minus 2, and your cos 60 is half, cos 0 is 1, so, and time taken is 0.2. So the induced EMF will be like negative of this, so it becomes, if you remove this becomes 10 power minus 3, so 25 into 400, so 10 to the power minus 1 into minus half divided by 0.2, so 100, 10 to the power minus 1, and then it becomes 10 to the power minus 1 divided by 0.4, so 10 power minus 1, so it becomes 1 by 4, it is 2.5 volt. So the correct answer is 2.5 volt. C will be the answer. So here we had to find the change in flux in a given time interval. So the induced EMF becomes rate of change of flux, time rate of change of flux. So the correct answer is C. Very straightforward question. So in this question, it says the magnetic field in a plane electromagnetic wave traveling in glass. So this is to be should be noted that the wave is traveling into glass whose refractive index is 1.5. The equation is given by this. where x is in meter and t is in seconds. We need to find the value of alpha. So you see the standard equation, in that standard equation by will be b naught sine kx plus omega t. So here if you compare, b naught comes out to be 2 into 10 power minus 7 Tesla, k is alpha, omega is 1.5 into 10 power 11 hertz. Now we know since refractive index n is given by speed of light in speed of EM wave in air divided by speed of EM wave in medium. So this becomes C divided by V, and that is equal to 1.5. Also, V of electromagnetic wave in a medium is also given by omega by k magnitude. So omega here is 1.5 10 to the power 11, k is alpha. So we substitute this value of 2v here in equation 1. So 1.5 will become 3 into 10 power 8, that is speed of light in air, electromagnetic waves in air, and it is 1.5 10 to the power 11 divided by alpha. So solving this, alpha will come in the numerator. Alpha is equal to 1.5 into 1.5 divided by 3 into 10 power 8. Should be in meter inverse. So 0.5, it comes out to be 0.75 10 power minus 8 meter inverse, which is 0.75, which is 7.5 into 10 power minus 9 meter inverse. So 7.5, why it is coming out to be minus 8. Oh, so we forgot to cancel this 11. So it should be 10 to the power 11, and when it gets cancelled, it gets sent 10 power minus 3, 10 power 3. So it should be 10 to the power 3, and if you solve it, 10 to the power 2. So correct option is C. Pretty interesting. So guys, question number 5, it says a charged particle is moving in a uniform magnetic field B with a constant speed of V in a circular path of radius r. Now, which of the following graphs represent the variation of radius of the circle with the magnitude of V? So let us see the situation. Magnetic field, suppose magnetic field is going inside the paper. So magnetic field is this, a charged particle is moving in a circular orbit. Now if charged particle is moving in circular orbit, the magnetic field is acting towards the circle and centripetal force is acting outward. For the stable circular orbit, these two forces must balance. So magnetic force must be equal to centripetal force. That means QVB sine 90 degrees, because particle at any instance is moving on the plane of the paper and then magnetic field is going inside, the angle between them is 90 degree. Centripetal force is mv square by r, so vv gets cancelled you have R is equal to mv divided by qb. We clearly see that R is inversely proportional to B. So inverse proportionality graph is only represented by graph number. This is constant, this is directly proportional, this is quadratically, this looks like parabolic, so it is quadratic. The inverse graph is this B. The correct answer is B. This is kind of conceptual question. It says which of the following statement is not true for an electrical energy in AC to that of the DC form. So there is comparison between AC and DC form. You see, first option says production of AC is economical. That is true. ACs can be produced using wind power, hydroelectric power, thermoelectric power. So that is pretty much economical as compared to DCs. DCs are generally batteries, you know, inverter batteries, car batteries, AC batteries, they are pretty expensive. So AC production using is economical as compared to DC. Next, AC can be easily and efficiently converted from one voltage to other. That is also correct because you can use transformers. You can step up transformer to increase voltage, output voltage, and if you use step down transformers, the voltage will be can be downgraded. The third is AC can be transferred easily over a long distance. That is also true. ACs can also be transferred easily. The fourth is AC is less dangerous. That is false. Why? Because AC is alternating. So this is DC. So the AC of the same magnitude as DC, this is VRMS. This point is VRMS, the average value, root means square value. So a DC of 220 volt, let's say 100 volt, AC of 100 volt and DC of 100 volt. 100 volt AC means VRMS is 100 volt. Now, what is its peak value? This is V naught peak value. So V naught is root 2 times of VRMS. So it turns out to be 1.414 into 100. It gives 141.4 volt. So AC of 100 volt can give output of 141 volt, you know, like it's 41%, 42%. The peak can rise you know, above to a value of 42% of its average value. So ACs can, you know, shock, can give you know, higher shock. So if someone unfortunately get attached to AC, it can shock with a maximum value of V naught, which is root 2 times or 40% more than the RMS value. So ACs are more dangerous than DCs. So the correct answer is this. This statement is false, and you need to choose incorrect answer. The correct answer will be D. This question, the energy of an electron in an orbit of hydrogen atom is 3.5. It's minus 3.5 electron volt. You need to find the angular momentum. So you know energy in an orbit is given by minus 13.6 by n square. So n square will be minus 13.6 divided by minus 3.4, which is 4. So n will be plus minus 2. Since n cannot be negative, we choose n equal to 2. So electron is revolving in the second orbit. Now, as per Bohr's postulate, angular momentum is nh by 2 pi. So here n is 2, 2 gets cancelled, it is h by pi. The correct answer is C. Pretty straightforward. So this question asks the RMS, that means root mean square, and the average value of an AC voltage The AC voltage is given V naught sine omega t volts over a cycle respectively will be. So this question is pretty straightforward. The correct answer is C, but we'll see how. The sinusoidal waveform is given by this. This is T and you have V. This point is V naught. So we want to find average value over a cycle. So over a cycle means 0, pi by 2, pi, 3 pi by 2, 2 pi. So this is a cycle. You see clearly the average will be V average will be, if you sum this positive cycle, V plus of V minus divided by 2 comes out to be 0. Now let us find out RMS. V root mean square will be square root of V naught sine omega t d omega t divided by 1 by 2 pi. So we average over the whole cycle 0 to 2 pi and then integrate this EMF over 0 to 2 pi. So this comes out to be, so square. So root means square of the so I'm taking squares root and its mean. So V naught by 2 pi 0 to 2 pi, and this is 1 minus cos, this minus 1 minus cos 2 omega t divided by 2 d omega t. So it becomes V naught by 2 pi integration comes out to be 1 by 2 omega t. So it will be better if you replace omega t with theta. So this is theta, this is theta, this is theta, this is theta, because in a circular orbit, if omega is an angular frequency, then in time t it traverses an angular displacement which is omega t. So it is easier with respect to integration. If you replace omega t with theta, the integration becomes easier, and then cos will be sine 2 theta t 2 by 2, 0 say 0 to 2 pi. Now if we put this value V naught square by 2 pi, upper limit and lower limit you take half outside, so 1 by 2 pi minus 0 minus, if you put sine 2 omega 2, this becomes sine 4 pi minus sine 0. So in both the cases this portion is 0, sine of 4 pi is 0, sine of 0 is also 0. So we are left with this 2 pi will get cancelled, V square by 2. So V RMS comes out to be V naught by root 2. Because when you solve this, it comes out to be 2 pi by 2 into 2 pi gets cancelled, you have V square by 2, so it is V by root 2. So we take just the positive part, so the VRMS is this is VRMS, which is V naught by root 2. The correct answer is C. To next question, question number 9. It says the figure shows 3-point charges kept at the vertices of triangle ABC. So there are three charges at the vertices ABC, 2q minus q plus q. The net electric field due to this system of charges at the midpoint m of the base will be. So here we want to find the net electric field. Now you see this is negative, so the electric field will be along this direction, and due to positive it will be along the opposite direction. So these two electric fields will cancel each other because distance and value of charge is same. They are equal and opposite. Now the net electric field is only due to 2q, charge 2q, which is at A. So that is positive, so the direction will be along AM. So, since direction is along AM, this option gets cancelled, this option gets cancelled. We have two candidates, B or C. We'll find out the value. If this is L, this is L root 2, using Pythagoras theorem, this becomes L. Now, the electric field will be K Q 2Q by L square. Value of K is 1 by 4 pi epsilon naught. 2q by L square, 2 gets cancelled, so you have 1 by 2 pi epsilon naught q by L square. The correct answer is A along AM. So A is the correct answer. Now in this question, it says there is a nuclear reaction which is X going to Y plus Z. Clearly, since two daughter nuclei are getting formed from X, that means this is nuclear fission reaction. The mother nuclei is getting broken down into two daughter nuclei. Now, Mx, My, Mz are the masses of the nucleus. Then which of the following relations hold true? We know that we know the concept of mass defect. So this tests the concept of mass defect. What is mass defect? The sum of the masses of the individual nuclei is greater than the mass of the combined nuclei, because when the nucleons gets into the nucleus, there is binding energy. So due to binding energy, some of the masses gets converted to binding energy. So the composite nuclei is slightly lighter as compared to the component daughter nuclei. So in this case, the X should be lighter than the sum of the masses of Y and Z. The correct option is D only. So a pretty interesting question. This is another interesting question. You say 2 point R and S are equidistant from two charges plus Q and minus 2Q. The work done in moving another charge minus Q from point R to S is. So let us try to solve it. Visualize it. So you have 2 point charges plus Q. Let this point be A and this point be B. The another charge is minus 2Q. Now 2 point charges R and S are equidistant. Now equidistant means let this point be R and this point be Q. Then R and Q, R and S, these 2 points R and S are equidistant from B and A, and here as well they are equidistant. Now the potential at R will be V at R will be K Q minus 2Q by, let this distance is X, not X, this will be AB AB, and since like AR not AB, and this, since this is equidistance, AB is equal to AS, and potential at S will be KQ minus 2Q by AS. Now since AS and AR and AS are same, potential is same, so you can say that VR is equal to VS. Now the work done will be, suppose a charge minus Q is moved from here to R to S, the work done will be minus Q, potential at R, final potential potential at S minus potential at R. Since these two potentials are same, it is 0. So work done is 0. So the correct answer is A, 0. So A. Interesting. Question, we have to find out the radius of the nucleus of a nuclei whose mass number is 125. So the relation goes like this. R is equal to R naught A to power 1 by 3, where A is the mass number. Now value of R naught is 1.2 10 to the power minus 15 femtometer, like 10 power 15 meter or just 1.2 femtometer. So we'll take 1.2 femtometer. Therefore, radius will be 1.2 into 125 to the power 1 by 3 femtometer. So 1.2 into 5 femtometer, which is 6.0 femtometer. So correct answer comes out to be A. It was very easy and straightforward question. This is an assertion and reasoning question. In the rule for assertion reasoning question is, if assertion is right and reasoning is right and reason is correct explanation, the answer is A. If assertion is right, reason is right, and reason is not correct explanation, then the answer is B. If assertion is wrong and reason is right, no, assertion is right and reason is wrong, so answer is C. If both of them are wrong, then option is D. Now, the assertion says in Young's double slit experiment, the fringe width for the dark and the bright fringes are same. It is true. We see Young's double slit experiment and the fringes are like this, equal bright and equal dark. Now the reason says the fringe width beta is given by lambda d by d. So this fringe width don't discriminate for dark and bright fringes. Both of them have got the same thickness for dark as well as for bright. So this formula governs both the dark as well as bright fringes. So reason is correct explanation of assertion. So correct answer will be A. So this assertion reasoning question says, the assertion says energy is released when heavy nuclei undergoes fission or light nuclei undergoes fusion. That statement is correct, because if when heavy nuclei undergoes fission, the fission reaction releases energy, because if you see the binding energy curve, so this is mass number and this is binding energy per nucleon. This is iron, which has got like more stable nuclei. Now you see, this heavy nuclei has got slightly lower binding energy per nucleon. When they break down, they achieve a slightly more binding energy per nucleon. That in turn releases energy. Whereas the lighter nuclei, they fuse together, they also move towards greater binding energy per nucleon. In turn, they release more energy. Now, so assertion is correct. Now the reason says for heavy nuclei, the nuclei is on this side, binding energy per nucleon increases with increasing G. That is incorrect, because when the G is increasing, that is A is increasing, the binding energy is falling slightly, right? And for lighter nuclei, if G is increasing, that is atomic number increasing, when atomic number increasing, the binding energy is increasing, it's not decreases. So the reason is false. So assertion is right, reason is false. The correct answer will be C. C is the correct answer. Now we move to question number 15. It says, assertion says the photoelectric effect is spontaneous process. This question is slightly controversial. I think CBSE will have to either give marks to everyone or just delete this question. CBSE will I think give marks to everyone in this question, because the wordings are wrong here. Photoelectric effect is spontaneous is wrong statement, and there is no such option in assertion reasoning where assertion can be when assertion is wrong and reason is right. So you see, if we'll see reason here, reason says according to the wave picture of radiation, an electron would take hours, days to absorb sufficient energy to overcome the work function and come out of from the metal surface. Now you see the wave picture. Wave picture says when wave will arrive on metal surface, see, all of the electron will start absorbing energy. So for a particular electron to come out of the metal surface, the energy absorption may take hours or even days. Precise calculation says that it may take days for an electron to come out of the metal surface to overcome the work function if we see the wave picture of the light. So reason is correct. Now, what is problem with this photoelectric like effect is spontaneous. Spontaneous is something which can occur on its own, like river flowing down the hill is spontaneous process. Like rivers don't climb above the hill on its own. One will have to invest some energy to make river go down up the hill. Similarly, for photoelectric effect to take place, one will have to bombard it with laser or some sufficiently high energy light, then only an electron will get ejected. So this is not spontaneous. CBSE wanted to write instantaneous here. Instead of spontaneous, it wanted to write instantaneous. Instantaneous and spontaneous are not same. So this question is wrong from CBSE. So I guess this the CBSE will give marks to everyone for this question. Now, assuming CBSE wrote instantaneous, then assertion is also right and reason is also right. So correct answer should be B. But I think CBSE should correct its mistake here, and in my opinion, CBSE will give marks to everyone for this question. Now we move to question number 16, which says induced EMF produced in a coil will be more when the magnetic flux linked to the coil is more. This is wrong statement. Magnetic flux linked to the coil will not produce more EMF, but the change in magnetic field should be more, not just the field. So EMF should be minus n d phi by dt. This change in magnetic flux with respect to time should be more for the EMF to be more. Now the next says induced EMF produced is directly proportional to the magnetic flux. No, it is not directly proportional to the magnetic flux. Induced EMF is directly proportional to the rate of change of magnetic flux. So both the statements are wrong. So the correct answer in this case will be D. Interesting. Now we move to section D, which has like case based questions. Now it says there are two parallel plates like separated by distance 0.01 meter, and it is connected to a 200 volt DC supply. So the plate above is positively charged and the plate below is negatively charged. The length of the plate is 0.05 meter. An electron is moving with 3 into 10 power 7 meter per second horizontal to the plate. Now the question, the plate itself is placed in XY plane. Now the first question, the electric field in the region between the plates. E between the plates will be how much? So electric field will come from plus to minus, so it will be electric field will be directly like this. The value of electric field is given by V by R. So V here is 200 volts and the radius, that is the distance between them, is 0.01 meter. So it is 2 into 10 to the power 4 volt per meter. Now you see the plates are placed in XY direction, and then the potential is going towards the negative K direction. So it should be minus 2.4 2 into 10 power 4 volt per meter K bar. So the correct answer should be Option D. Now we move to the next part of it. It says the region between the plates, acceleration of the electron. We need to find acceleration of the electron. You see the force acting on the electron is QEE. Now force equal to mass into acceleration, which is EE. So acceleration will be EE by M. You see the electrons under the influence of the force should move like this. So the force is acting along the upward direction because electrons will naturally be attracted towards the positive charge. So the acceleration will be 1.6 10 power minus 19 into value of electric field is 2 into 10 to the power 4 divided by 9.1 into 10 power minus 31. Now it should be along positive z direction. So so it should come out to be plus 3.5 into 10 to the power 35 when gets subtracted from this is 15 meter per second square. The correct answer, and it should go towards k direction, is to positive k. The correct answer should be B in this case. The third part of the question asks for the time taken by the electron to cross this region. So you see the horizontal direction of the velocity remains unchanged. So the time taken will be the length of the plate, that is 0.05 meter divided by its velocity, 3 into 10 power 7. So it comes out to be 1.67 into 10 power minus 9 second. The correct answer in this case will be C. The OR part, third A, and that is third B, that is OR part. It is asking that vertical displacement of electron which travels from the between the plates. So this is the vertical displacement. This Y is the vertical displacement. So if you remember, we discussed this question while we were discussing most expected question. There were two plates. So the Y is given by U vertical T. Since we are finding out vertical displacement, half AT square. Initial vertical velocity is 0. So it comes out to be half. Acceleration is 3.5 into 10 power 15. Time is 1.67 10 power minus 9 whole square. So it should be 0. No, this should be 1.75, and then if you solve this, 1.75 into 1.67 into 1.67, it gives you 4 point, it is 4.88 10 to the power minus 3 meter. So it is 4.9 millimeter. So correct answer is B. The last part asks which track is correct track. So these two plates are there, plus plus plus, minus minus minus. So the tracks are indicated as B, D, A, C. Since electrons are negative, it should show parabolic path, so B should be the correct track. So correct answer is B. Now in this question, this is interference based question. It shows that coherent sources are are thrown on slits. Two slits are there and a pattern is observed. Now you see there are 6 fringes, 1, 2, 3, 4, 5. 5 fringes are, they are spanning between 3 to 3, minus 3 to 3. That means total 6 centimeters. So 5 fringes are in 6 centimeters. So what will be the fringe width? Fringe width is 6 divided by 5. That means 1.2 millimeter. So beta clearly is 1.2 millimeter in this case. Now the first part of the question says, what property of light does this interference experiment demonstrate? So clearly this demonstrates wave nature of the light. So the correct answer will be A. Wave nature of the light is demonstrated. Now we go to the next part. Next part, A asks the wavelength of the light used in this experiment. See, we have beta is equal to lambda d by d. So the lambda will be beta small d by capital D. Beta is 1.2 10 power minus 3. Capital D is 5. Small d is 2 into 10 power minus 3. So this gets cancelled. You have 0.6. So it is beta equal to lambda equal to beta equal to lambda d by d. No. So this is beta is 1.2 10 power minus 3, and it should be actually small d, and the capital D. Small d is 2 millimeter 10 to power minus 3, and capital D is 5.0. So it is 2.4 into 10 power minus 6 divided by 5. Divided 5 fours are 20. 5 into 10 power minus 6, which is 480 nanometer. The correct answer is C. The third part of the B part of this question asks the fringe width of the interference pattern formed. What is fringe width? So we have already calculated beta equal to 1.2 mm. So answer would be A, 1.2 mm. The third part says, so this was OR part of the question. The third part asks the path difference between the two waves meeting at X where there is minimum interference pattern is. So we have a point P on the screen. This point P. We want to find the path difference. See, the path difference for dark fringe Xn is given by 2n minus 1 lambda d by d. No. Path difference. This is the position. This will be lambda by 2. So you see, you have the first dark and the second dark. So n will be 2. So this comes out to be 3 by 2 lambda. So 3 by 2 lambda will be 3 by 2 into lambda is how much? How much is lambda? 480 nanometer. If solve it, it will be 240. That means 720 nanometer, which is 7.2 into 10 power minus 7 meter. So correct answer comes out to be B. B is the correct answer in this case. Now the fourth part, the last part says, when the experiment is performed in liquid, the refractive index is greater than 1, the fringe pattern will. So you see, beta is lambda d by d. When you perform this experiment in a liquid whose refractive index is greater than 1, only thing that will get affected is lambda, because the screen distance will remain intact, the slit width will remain intact. Lambda will fall, lambda will decrease. If lambda decreases, beta decreases, so beta dash will be less than initial beta. So fringes will shrink, so will be compressed. So the answer is D. So that were the discussion on objectives, section A and section D questions. They were most crucial part. The other parts B, C and E will be discussed later. They are theoretical and straightforward parts. We'll discuss those in next lecture. Till then, take care, guys. Bye.